Hello everyone, my name is Dian Lestari from Group 6 and today I will present our research poster titled A Hybrid Cost-Sensitive Ensemble Approach for Indonesian Local Script Handwritten Recognition. This research focuses on handwritten character recognition for Indonesian local scripts. The main problem is that many Indonesian traditional scripts are becoming less actively used because digital communication today mostly relies on the Latin alphabet. In this study, we work with 9 Indonesian scripts with 228 character classes and 55,713 handwritten images. Our main objective is to build a hybrid handwritten character recognition pipeline that can recognize all 9 scripts under one fair framework. The dataset also has a serious class imbalance problem with a ratio of around 14.5 to 1. Instead of using synthetic data or oversampling, we use a cost-sensitive learning approach. So minority classes receive more attention during training. For the computer science approach, we combine frozen CNN feature extraction with cost-sensitive boosting and weight ensemble voting. This allows us to avoid manual feature engineering while still keeping the pipeline efficient. Moving to the literary review, previous studies have used traditional machine learning models such as SVM, KNN, random forest, SGBoost, and LightGBM for script recognition. These models are efficient, especially with limited data. However, their performance may drop when the images are noisy or have high texture. Or other studies handle class imbalance using augmentation, GAN synthesis, image fusion, or external data expansion. These methods can help, but they might require more memory and may also change the original data distribution. Because of that, our research uses class weighting instead. CNN-based handwritten character recognition has shown strong results in many script recognition tasks, like lightweight CNN backbones such as MobileNet V2 and AffiliationNet B0 can extract strong visual features with lower computational costs. This is why we use them as frozen feature extractors in our method. The research gap is that there is no prior study that benchmark all 9 Nusantara scripts together, applies cost-sensitive learning without manipulating the data, and combines pre-trained CNN features with gradient boosting ensembles for this multi-script handwritten character recognition problem. Next, for the writing strategy, this research uses an experimental quantitative approach. We compare 6 individual model combinations and 2 ensemble voting strategies using a fixed 80 to 20 stratified train test split. Certification is important because it keeps the class proportions balanced between training and testing data. For evaluation, we use macro F1 score as the main metric, supported by macro precision, macro recall, and per script performance analysis. Macro F1 is suitable because it gives equal importance to every class, including minority classes. Now I will explain the methodology pipeline. First, the images are resized into 224 by 224 grayscale images. Then output thresholding is applied and the images are converted into 3-channel RGB format. After that, MobileNet V2 and AffiliationNet B0 extract 100 1280 dimensional frozen CNN features. Then we apply PCA to reduce the feature size into 256 dimensions. PCA preserves around 91.9% variance for MobileNet V2 and 94.1% for AffiliationNet B0. This helps reduce competition while keeping most of the important information. For classification, we use SGBoost, LightGBM, and CatBoost. These models are trained using balanced class weights. The weight range is from 0.337 to 4.887, representing the 14.5 to 1 penalty ratio. Finally, the models are combined using a weight vote ensemble, where stronger models have greater greater influence in the final prediction. Now let's take a look at the result. The best model is Waitfoot with six models achieving a macro F1 score of 0.9160. Softfoot is slightly lower. The best individual model is Catboost with MobileNet V2 with a score of 0.8770. This mean weighted foot improves the best individual model by around 3.90%. For per script performance, the strongest script are Lontara, Palawi, Kawi, and Lampung. Lontara achieves the highest score with 0.9892. The lowest score is from Jawa with 0.7464. This lower performance is mainly caused by morphological ambiguity, meaning several characters have very similar stroke structures. The result show that cost-sensitive weighting helps protect minority classes without generating synthetic data. This is one of the main contributions of our research. This research also considers responsible computing. We support transparency through open dataset and public code. We also support cultural preservation by using AI to help digitize and recognize Indonesian local scripts. In addition, macro F1 and class weighting help improve fairness for minority script classes. In conclusion, our proposed pipeline successfully combines frozen CNN features, PCA, cost-sensitive gradient boosting, and weighted vote ensemble for Indonesian local script handwritten recognition. For future work, we suggest script-specific augmentation and partial CNN fine-tuning, especially to improve recognition for visually similar script such as Java. That's all from me. Thank you for listening to my presentation.